Hello, I'm Steve Greb. I'm the director of GeoAquaWatch. I'm also the lead for the Sediment team for CS Coast effort. Today I want to talk a little bit about sediment transport and loading. As many of you know, when we talk about sediment, there's a number of ways we can measure it, whether it's total suspended solids, turbidity, total suspended matter, Secchi disk, or say KD 490. We do know there's a strong connection to the land. The suspended solids material comes off from soil erosion, runoff, and discharge. We also know that a lot of sediment comes from resuspension of the bottom or from algal blooms. We also know that sediment impacts the light field and consequently affects productivity and dissolved oxygen of the water. The sediment can be laden with nutrients, pollutants, and pathogens. And one of the reasons we're concerned is because of the coral reef health and to shellfish. We also know there can be a connection between climate change and the increase of the sedimentation. We're getting really good at measuring suspended solids from space. Remote sensing reflectance and total suspended solids have a high correlation in the green, the red, and the near infrared spectral bands. And we see many examples in the literature now of successful correlations between these bands and total suspended solids. But we also know this relationship varies with the sediment composition. There's a number of operational efforts now which are displaying some form of turbidity or suspended solids in the water. A couple examples here. One is the ESA Climate Change Initiative in the top, and on the bottom we show two examples, one being from VEERS, one from MODIS, that can be found on the NOAA Aqua or Coast Watch site. I want to tell you a little bit about a project that GeoAquaWatch has been involved with, and that is bringing together these disparate data sources, be it from satellite remote sensing or from in situ. Here I've loaded three data sources on here. One's from the Copernicus and the other is from the GEMS water database. If we zoom into Chesapeake Bay here, and let's slide the turbidity to the right, we can start to see the colors form in Chesapeake Bay. We see the variability of turbidity from, this is from 5/12/2020. If we go on and we click on a particular point and hit the probe, we can see the actual concentration of turbidity. One of the other things we can do is animate this. Here I've chosen a time period from April to July of 2020, and we can see how turbidity changes over time. And finally, if we click on the GEMS database and slide that to the right, we can see points showing up where there's actual Greb samples being collected at given times during this time period. If we are to stop the animation and click on one of these points, we can actually see the concentrations, in this case, of dissolved organic carbon at that particular point. The other project I wanted to tell you about that AquaWatch is involved with is the development of a Google Earth Engine global water quality geospatial products and tools. This is a large collaborative effort between GeoAquaWatch, the World Bank, Conservation International, UNESCO, and Google Earth Engine. And as stated here, the goal is to provide a global scale, open access, freely available, fit for purpose water quality information for both inland and coastal waters to be used by a number of users, be it the science community, water resources managers, industry, or the general public. So finally, I'd provide the contact information here. If you're interested in joining the sediment group or just getting involved in AquaWatch, please contact us, either Mary Beth or myself, at these email addresses. And please go to our website and visit us at geoaquawatch.org. Thank you.